Okay, so today I am teaching lesson 3.5 number 2 and lesson 3.5 number 3. And there are a few topics in here that are different than what you're used to. ln of x squared equals 6. We haven't done many like this. So there's a couple different ways you could do this. What if I trained you that whenever you see ln, what should you write? Log base e. So I'm going to do that. Could you rewrite this thing? Yeah. When I rewrite it, what do I get? E to the 6th equals x squared. All right. Is x alone yet? No. So what do I do? Square root. What is that the same as? Power of what? Okay. And then when I do to the power of 1/2, I've got x alone, and I've got e to the 3rd equals x. Except you all just forgot something. I just took a square root on both sides. What's supposed to happen? Plus or minus. So it's actually plus and minus this. That means I have x is equal to e to the 3rd, and x is equal to negative e to the 3rd. But if I go back to the original problem, can I put in a negative e to the 3rd and have it come out okay? Am I allowed to have a negative e to the 3rd right there? See, them, you guys aren't that good at this. Can you or can't you? And some of you are saying yes, some of you are saying no. You can because it's squared. Very good. See, negative e to the 3rd. It would be a problem except that it's being squared. So if it gets squared, then it won't be a negative there anymore. Get what I'm saying? Once we square that thing, it won't be negative, and it'll be okay.
So if there wasn't the square there, you couldn't...
If there wasn't the squared there, then you wouldn't be allowed to have a negative in the argument. So it's like this. Let's say that we had this. Log base x of 3 equals 12. This is the simple kind. And then if you have a negative, it can't be in there. Okay? But what if it's like this? Now it depends. Some negative numbers would be okay. Like, do you get how I could put in a negative 2 there and it would be okay? Because negative 2 plus 5 makes positive 3, and it doesn't make the base negative until the negative gets big enough. What if the x was equal to negative 5? Is that okay? Can I put in negative 5 there? No, because then I'd end up with negative 5 plus 5, which would be 0. The base would be 0, and then it's not allowed. So it's not just as simple as if you get a negative number, it doesn't work. It depends. If you put the negative number into the problem, then you check. Like if you came out with negative 5, you should say, wait a minute, I'm going to get a base of 0. That's not allowed. So that's an extraneous answer. Can't work. What if on the same problem I had x equals negative 2? Is that okay? Yeah. That doesn't make the answer come out correct, so I'll maybe change the answer to make it actually work. There's an example where x equals negative 2 is an answer that actually works. Because when I put in negative 2 right here, I end up with a base of negative 2 plus 5, which is 3. And if the base is 3 and this argument is 3, the answer comes out to 1. So yay, it works. And it's a negative number. So don't just tell me that every time it's negative you cross it out. It depends on the problem. You stick the number in and see if it causes a problem. One more. Log base x. Log base, it's like 4, of x minus 5. Let's say I came up with an answer on this one, and the x was supposed to be 2. Is that okay? No. Because when you put in 2, even though it's a positive 2, it ends up coming out with an argument of negative 3, and you can't have negative arguments. So x equals 2 would be an extraneous answer, even though it's positive. So the moral of the story isn't just that, oh, watch out for negatives. It's watch out for any answer that when you plug it back in, causes the base to be negative or the argument to be negative. The other side over here, the number that's over there, that can be negative all day long. No big deal. Don't care. It's only these two, that and that. When you stick in your number, they better come out positive. They can't be 0 and they can't be negative. All right, enough on that. Next topic. Let's talk about quadratics. Do you remember when we had this? You'd factor your quadratics and you get something like that and you get two different answers. We're going to have a lot of those today. So, except that they're not going to look like this to start with. They're going to look like this. Log of 2x plus 1 plus log of x minus 4 is equal to log base 9 of 1. What I just wrote here totally turns into this after a little bit of work. Or close. It comes out close to that anyway. Okay, so I'm going to put these two together, and I'd have a single log of 2x plus 1 times x minus 4. Notice that was two logs becoming one log. Kind of like marriage log. The two become one. Then, log base 9 of 1. Ooh, I won the argument. What's one argument mean? 0. Now, though, I have to do a rewrite. What's the base on this guy? What's the base on this? 10. 10 to the 0 technically equals 1. And 10 to the 0 is 1. 1 equals all that. So then this one would be 2x plus 1 times x minus 4 equals 1. Again, I just did 10 to the 0 equals all that. Here, I better write it. You tell me, why would I do 10 to the 0? Oh, now you see it. 10 to the 0 equals all that. That's just a rewrite. And what is 10 to the 0 equal to? It's equal to 1. So 1 equals all that. So then I'd have to multiply it all the way out, set it equal to 0. This one has to come over and join up on this side, and then hopefully it factors again. Maybe you don't know what I'm talking about. So I better do this. 1 equals, multiply first outside, inside last. The first would be 2x squared. The outside would be minus 8x. The inside would be plus an x. The last would be minus 4. And then I'd subtract 1 from both sides. And I'd have 0 equals 2x squared minus 8x. Oh, wait, minus 8x and plus an x makes minus 7x. And then minus 5. And then, hopefully, this would factor. We've got them set up today, so pretty much all of them will factor at the end. This one may not. Oh, shit, maybe it will, though. I'll maybe get lucky. And a 5, let me think, a 5 and a 1. Outside, inside. Outside, then one of these needs to be negative. Outside's 2x, inside's negative 5x, so it makes a negative 3x. And didn't quite factor. It's close to factoring. All right. If it factors, though, let's say it had factored to this, we would be done, except we'd have to say, oh, so x plus 1 equals 0, x equals negative 1, and then 2x minus 5 equals 0, 2x equals 5, x equals 5 halves. There's my two answers. Then what would I want to do at the very, very end? Check and see if it actually goes back in, yes. So I'd go back in and put in, can I put in my original problem, which is the one that's circled here, can I put in a negative 1? Depends. Check. Do I come up with a negative argument? Yeah, I do. Negative 1 couldn't possibly work. All right. Okay, I was making that up at the end, though, because this did not factor nicely. I just showed you a lot of times they will. Okay, so there's that kind where they factor. Here's another kind where they factor. Let me think. Yeah, that one works. Okay. This isn't the base x, that's just a log x. Okay, so this kind are called U substitutions. So you're trying to substitute something in to make the problem easier. In calc, they're going to use the letter U. Some teachers use X, so don't be surprised if on the key it says X equals whatever. I recommend a U substitution just so you're used to it for calc. Do you get if I replace this log X right here and this log X right here with a U, that it'll just be a quadratic that you can just factor? Get what I'm saying? So what the original problem had a log X right here and a log X right here. So we let log X equal U, and we substituted in a U instead so that we could just have a nice simple problem to factor. Factor that one. Solve it. Get it down to like U equals 2 and U equals -5 or whatever it comes out to. Yes, ma'am?
So to substitute, you would have to be log base 10.
Nope. You can substitute anything. But I chose to get these log x's out of here because it would be a lot easier if that was just a variable like U. So I did this right here, and I replaced this and this both with a U, here and here. I just pulled out wherever it saw log x and I put in a U. That could have been log base 3, that would have been fine. It could have been log base 36, it doesn't matter what the base was. I just pulling out something that was complicated and putting in something simple. So what I wanted you to do right now is just factor that. I look like a cyborg. Can you remove the electronics? You too. Thank you. All right. So you should have said 2U and a U, and you should have said a 1 and a 1 and a plus and a plus. That was probably the easiest factoring around. Now let's check it and make sure it works. First is 2U squared. Good. Outside and inside makes 3U. Last makes 1. Hey, it worked. Cool. Did you actually solve it all the way yet? No, not yet. To get it all the way, so I'll just say 2U plus 1 equals 0. 2U equals 1, -1, sorry. U equals -1/2. And over here, U plus 1 equals 0, and U equals -1. Cool, I'm done, but I'm not done. Because I made the problem easier by taking out something complicated and putting in a U, now I got to finish the problem by paying the piper, so to speak. And I have to now go back and replace my U with a log x, because we said U is log x. So now we got to pay the piper at the end. Log x equals -1/2, and log x equals -1, and then solve those. This is a base of 10, right? Base of 10. So 10 to the -1/2 equals x. And 10 to the -1 equals x. Now, don't be confused that negative powers mean the answer is negative. It isn't. 10 to the -1 means what? 1/10. And 10 to the -1/2 means you take the square root of 10, and then the negative part of it means 1 over the square root of 10. Are either one of these negative? No. If my life depended on it, would I check my answers? Oh, yeah, that's for sure. Kind of like when you're designing your flying car. You probably want to double check it before you take it up to 2,000 feet. They have come out with a new flying car. If I were a bazillionaire, I think I would buy this one. Have you guys seen around Lake Minnetonka every now and then people are flying those kind of looks like a dune buggy kind of a thing with a big parachute over the top of it? And so they've come out with a commercial car that's like legal on the road that can pop a parachute like that and just start flying. So you could take it out, drive down the street, pop your parachute out, take off, and yep, and steer it, fly it in. I could land. I could lay it like land right out in the parking lot here if I wanted to. Just come in for a landing, and then you pull your parachute in, put it in a little box, and then go into school and teach. Wouldn't that be fun? You do have to have a pilot's license, but it's not like a normal one because it's not a normal plane. But wouldn't that be awesome? But I'd double check my work if I was the guy who was designing that, because if you screw that up and like the parachute falls off halfway home or whatever, you're now free falling in your little car. That wouldn't be very fun. Okay. Anyway, so I should probably double check those. Where would I put in the x equals 1/10 and x equals 1 over square root of 10? I would put them back in the original problem. I'd put a 1/10 right here. And that has a base of 10. And 1/10 is the same as 10 to the negative 1, which means this would be a negative 1 right here. Negative 1 squared would be 1. 1 times the 2 would be 2. So this whole thing is equaling 2. Over here, this becomes a 1/10. And then log base 10 of 1/10, that's really like negative 1, because this part right here is really 10 to the negative 1. Negative 1 times 3 is negative 3. So it's positive 2 for this, and negative 3 and a plus 1 equals 0. Is that really equal to 0? Yes, it is. So 1/10 worked. I went kind of fast, but 1/10 worked. What? Yes. Do you have to check all your work? No. Just it matters on the tests. Warning you, sometimes you have 2 answers, one of them doesn't work. What do you call that kind then? Extraneous. Have you ever seen extraneous answers come up on tests before? How about like on every single one? So just, I'm not saying that there is one for sure. I haven't even looked. I'm just saying, judging by all the other tests, probably be smart to check. Or what if you got a problem that comes out as simple as this, and you solved it down and you got x equals negative 2. Yeah, that's extraneous then, because you can't have a negative right there. Right? Okay. So watch out for your extraneous answers. All right. So use substitutions. I hope you'd see it if it looked like this. 3 log x squared minus 2 log x e minus 4 equals 0. Do you get the pattern? I have something squared, something that was not squared, and then a constant. If you ever see that pattern, it's a quadratic pattern. It's got something that was squared, something that's not being squared, and then a constant like 6 or any other number. Yes? You probably only want to do use substitutions when it comes to quadratics. But if you ever want to do use substitution, you absolutely can. You can do it anytime you want. 3x minus 5 is equal to 12. You could say let x equal u if you wanted to, couldn't you? Really wouldn't help very much, but you could. And you could solve the whole problem with a u in it, get the answer, and then swap it back out. Any problem in the world can have a u substitution. Let me give you another u substitution one. E to the 2x plus e to the x plus 4 equals 0. If you could pull out something complicated and put in a u, do you get how this turns into a quadratic? E to the x and e to the x could be pulled out, and you could let u equal e to the x. Then I have got a simple problem. U squared plus u plus 4 equals 0. And as long as that factors, which it might not, but if it did, let me make its factor so you can see what I mean. Let me see, outside and inside, 4, and let's do a 2 and a 2. So that would be a 4. So there should be a 4 in this problem right here. So there should be a 4u right here. All right? Factor that. and then finish the deal, because at the end, when your answer comes out, you better put in an e to the x instead of a u. So factor this in terms of u, solve it for u, then do the swap back again. Try it. Okay, so I hope you factored it into u plus 2 and u plus 2. Do you agree? Because the firsts make u squared, outside and inside make 2u, and 2u makes 4u, and the last make 4. Cool. If you can't factor that now, you've got to get that back in your head, because you were able to factor before, or you would have already failed this class. So now I'm going to have a u plus 2 equals 0, u equals negative 2. And I'd get the same exact thing on this side, so there's no point in doing it again. So u equals negative 2. Am I done? No, because we made the problem easier up here by letting u equal e to the x. We got to let u be e to the x. E to the x equals negative 2. Is this solved? No, it's not. Then you rewrite it. And what would you get? Log base what? E of what? Negative 2 equals what? And now what do you know? Extraneous, or no solution's even better, because it's not like we came out with a solution that didn't work. We came out with a negative in the wrong spot. That's a no solution. The answer is no solution. And why? Because you'd probably want to note and say like that. I don't want to argue with you. You can talk later. Okay. Any other questions? All right, so let's move on to actual homework problems. I'm going to pause for a second while I get out these homework problems. All right, so here we go. We are on worksheet 3.5, number 2. Thank you. And I'm going to start the very first one there with, we actually did that one in class. So that will be easy for anybody that was paying attention. Number 1 is an easy one. Now, given that I only have 2 worksheets that are pretty easy, and we have 2 full days of class today and tomorrow all day, I'm not going to cut out any of these problems. So I did do some of them, or ones like them, for practice already. Let's do number 4, because number 1 will be easy for you. Number 4, this is off worksheet 3.5, number 2. Number 4 says ln x to the 6th equals 12. The first thing I trained you to do was to say log base e. There, I've rewritten it with log base e. Now I should probably do a rewrite. E to the 12 equals x to the 6th. E to the 12 equals x to the 6th. Is the x alone yet? That's what you got to keep asking yourself. You keep going until the x is alone. Okay, the x is not alone, so we put it to the power of 1/6. 1/6. And as soon as I do that, I have absolute value of the x. Because we did a square root, it's an even root on both sides. This part becomes pretty easy. 12 times 1/6 is 2, so it's just e squared. But I need a plus and a minus. So x equals positive e squared, and x equals negative e squared. And if you think, well, the squared would just cancel the negative anyway, not unless there was parentheses. If this had a parentheses, then you're right, they'd be the same thing, but there aren't parentheses there. Okay, so there's my 2 answers. Now I should double check and make sure that actually both of those really work. If I put it back in here, and the x is what I'm checking, this x right there, if I put in the positive and the negative, would they both work? Yep, because when I have a negative e squared, that's the only one I'd be worried about, then the negative does get squared away because it's in parentheses. That x right there is like an empty parenthesis. So when you drop something in there, it's like it's in parentheses. So bottom line is both of these would be okay, because this is not a problem because it's being put to the 6th power. That'll make the negative go away. And that makes it legal. So there's both answers. E squared and negative E squared. Yes, sir. Good question. If you're taking a cube root like this, if I had taken a cube roots don't cause that problem because cube roots of negatives aren't a big deal. The answer to the cube root of negative 8 is just negative 2. No biggie. No absolute values needed, nothing. Depends on the problem. Always take your answer and double check it. Depends on the problem. Some answers, remember how we talked about this? Just because it's negative for an answer doesn't mean it's wrong. Depends on the problem. Stick it back in, see if it works. Yes?
Can we just leave it as 12?
The final answers were here. These are the two final answers. You should be able to say 12 times 1/6 is 2. You should be able to do that. Those are easy numbers. 12 times 1/6 is 12/6. And 12/6, you can make 2 out of that. You can do that. All right. I want to help you with number 6. Not going to talk about that one anymore. Number 6. 1/4 to the x minus 1 is equal to 8 to the 2x minus 1. This one's kind of a trick problem. Not trick, really. It's just that you're so used to rewriting that you're going to assume you want to rewrite this thing as a log, but you really don't want to. Because if you could get these two bases to be the same, then the answer would just be setting the exponents equal. Both 8 and 1/4 can both be written as a 2 to a power. So you want to rewrite this Do you get how all that blue stuff is just a carryover from what was above? And now I really wish it was a 2 to a power. And it is. You just got to figure out what the question marks are. 2 to the what power is 1/4, and 2 to the what power is 8. And once you have that, you got your bases the same. This will equal that, and you'll have to solve your little equation out. So 2 to the what is 1/4. Well, you got to use a negative power to make it a fraction. You got to square it. I'll let you figure out what that one is. This one's a nice simple whole number. Okay, enough help on number 6. Again, I don't want to do too many of these because, you know, there's only so many to do. All right, let's go on to number 11. I want to help you with number 11 because it brings up an important topic. Remember condensing logs? You'd have 2 logs and you'd squish it down into 1. That's what we did for the first couple days of this assignment. Log base 6 of x minus log base 6 of x minus 1 is equal to log base 6 of 3. Okay. If I could get these two squished down into 1 log, then I'd have logs that have the same base on both sides, and I'd be able to cancel those. So let's get this squished down into just 1 log. Log base 6 of what? Well, when you have a subtract here, what does that turn into? Divide. So it's x over x minus 1. And now, this cancels this. If they have the same log base on both sides, I can cancel them. It's actually a complicated process of rewriting it and all that stuff, but it's just a lot faster if I take that shortcut and say x over x minus 1 is equal to 3. And now, you got to remember back to at the beginning of this course, we taught you about clearing fractions. Does this have a fraction in it? Yes, it does. How do you fix that? You multiply by the reciprocal of the. You want to get rid of the what? Okay, come on now. What do you have to get rid of to get this not be a fraction anymore? The denominator, the x minus 1. So you multiply by the denominator. The denominators are canceled that way, and you'll be almost done. X equals 3x minus 3, and then you solve it from there, and you should be able to solve that. That's little kid algebra you did back in 6th grade, maybe 7th. Okay, so that's the last hard concept that we had to talk about for the video. I will do a couple more off of the next worksheet. Everybody put that worksheet away, please. And now take out the worksheet 3.5, number 3. At the top of that worksheet, listen. At the top of worksheet 3.5, number 3, I would write use substitutions, because that's what pretty much the whole page is about. Doesn't mean every problem, but there's a lot of them on there. 3.5, number 3 is all about use substitutions. All right, I'm going to look at number 1. Would you do a same thing we talked about on the last problem, number 11 we just did? Would you do a condense, sorry? Log x minus 2 plus log x plus 5 is equal to 3 log 2. Okay, condense. To get that down into 1 log, it's log of something. No. That's a plus, so what do you change pluses into? Multiply. So we have something times something. What is it? X minus 2 times x plus 5. Very good. Equals, those parentheses around the outside of that are kind of unnecessary, but equals, and then this 3, I'd put it up as a 3 on the 2, 2 to the 3rd, and then that's really 8. So then I'd say this is log 8. Would you agree that I have log base 10 on both sides? Cancel, cancel. X minus 2, x plus 5, and then from there, you have to multiply it all the way out, set it equal to 0, so that means move the 8 over to the other side. It'll factor, promise, it'll factor nicely. You get an answer. I did not need to do a use substitution on that one, but you will on a lot of the other ones here. All right, I know you know how to factor and stuff, so you should be able to finish number 1 all by yourself. Let's move on to number 2. Number 2 on your worksheet says 2e to the 2x plus 5e to the x minus 3 equals 0. What's that I smell? Oh, it's a quadratic. That's what I smell. Because that right there and that right there are something complicated, and I can pull them out and I can make them into u's, and then I have something squared, something that's not squared, and something that's a constant. And that is the pattern for quadratics. That means it's going to be a quadratic. Once you solve it, I bet you anything it factors nicely. And then once it's factored, I get the answer. And then I got to pay the piper because I'm letting e to the x equal u, and that's going to make my problem easier now. And once I'm all done, though, I'll get my answers like u equals 6, but I'm not really done because then I got to go back and put the e to the x in back at the end and solve it from there. Watch out again that you don't get an answer that's extraneous. You get an answer that doesn't really work. That would be a problem. All right, number 4 stumps a lot of people. I know you're not done with that one, but telling you, go to number 4 right now while you got the help. So I'm going to be stopping very soon. Any ideas? Anything you could do, do you think? Put both sides to the 1/2 power. It's a very good guess, but wrong, because it's going to be really complicated to put this and square root it. So good guess, but no. Oops. Anything you can do that would make this simpler. Ooh, yes. But this right here needs to go down somewhere first. down to the front. There. Then I can substitute log x in u. So let u equal log of x. Or I could have said let log of x equal u. It doesn't matter.
Why does it have to run on the front first?
Did I say that? It had to be in the front first? I'll say it again. You could say u equals log x, or you could say log x equals u. Either way is fine. Oh, why does the 2 have to go down in front first? Because otherwise, wouldn't you have had a u squared? Isn't that totally different than a 2u? Yeah, it is. So if you're going to pull out the log x, it would leave that squared dangling, and the squared is not really a log x. Here, how about this? Yes, here's the key. That is different than this. Those are different things. On this one, I could pull out the log x and put in a u. On this one, I could not until I get that 2 out in front. Then I could pull the log x out. Okay, I know it's kind of picky, but it is true. So I don't know if that was a good enough explanation, but bottom line is, yeah, you had to pull the 2 down in front first. Can we stop now? And this is u squared equals 2u. There, we're getting close. Any quadratic, you always have to set it equal to 0. And then it'll factor, this one will factor really easy. Just factor a u out. So anyway, once it's all done though, you'll have 2 answers, u equals 0, and then some other answer. See, there's u in both of them. There's u here and there's u there. Just pull a u out. It's like 25 minus 2 times 5. There's a 5 in both of them. Pull a 5 out, and you'd have 5 minus 2. Anyway. All right, so when you're done, you'll have 2 simple answers, u equals this and u equals that, and never stop there because u is only a placeholder. You got to substitute back in your log x and solve it from there. So once you're down to u equals 0, you say, oh, but u isn't an answer. U is this placeholder. Log x equals 0. And then you resolve it and you figure out, oh, x must be 1. All right. Okay. One more to help you with. Look at number 6. Who can see something on number 6 that will simplify down really nice and easy? Yeah, explain. What do you mean? Why can log 10,000 turn into a 4? I don't get it. It's base 10. And then, what else are you going to change? Change the 10,000 into 10 to the 4th. That makes it really clear why that'll simplify down to 4. Then, how are you going to get this squared off of here? Put it to the 1/2 power. That's also known as taking the square root of both sides. So I'll have this. Now I'll take the square root of both sides. The square root of 4 is nice and easy. It's 2. If I take the square root of both sides, you got to remember to put in the absolute values, and don't forget you'll have a plus and a minus answer. It's happened on 5 tests. It's probably going to happen again. All right. Okay, I have. Oh, I guess I can remind you on the back side of the number 3 worksheet, look at number 11. That's a prime example of get the clump alone. To get the clump alone, what do I do to both sides? On number 11. Yep, you divide by 4 to start with. That'll get the clump alone. This is the clump. Then I can rewrite it and use a log. Log base 1/3 of blah, blah, blah equals blah, blah, blah. So start by dividing by 4. 1/3 to the x over 4 is equal to 9. And then you do a rewrite. Make a log out of this. Anytime the x is in the exponent, you want a log to solve your problem. That's what logs are for. Logs will get the x out of the exponent. All right. That was a little bit longish lesson, but it did cover a lot. Two full days. So tomorrow when you come back, you're going to have a work day on both those worksheets. And if you need help, I'll be back for sure on Thursday morning. I'm not certain I'll be gone tomorrow, but I'm probably. And that's all I have for the lesson for